Hello friends, welcome to our YouTube channel Maths Olympiad by Subbarao. Today our topic is heights and distances. This heights and distances part of the trigonometry. Instead of part of the trigonometry, I can say one of the application of the trigonometry. This heights and distances is one of the application of the trigonometry. Next, to solve the problems using heights and distance application, first of all, we must know one thing, that triangle should be right angled triangle. To solve any problem using heights and distances application, use right angled triangle only. This is first point. Then comes to second point, line of sight. What is line of sight? So any ray that is our sight, here this is called line of sight. This is straight. Line of angle of elevation means above the line of sight, whatever may be the angle, that angle is called the angle of elevation. Next, angle of depression. Angle of depression means below the line of sight. Below the line of sight. Example. Now I am seeing straight. So this is a line of sight. Whereas I am seeing like this. So above line of sight, that object. So the difference between the line of sight and whatever the angle of elevation. Similarly, this is a line of sight, straight. If I am going to see the object and down, so line of sight and this angle, that is called the angle of depression. To measure the any height of tower or any height of tree or any tallest object, and distances, width of the river. So like this, there are so many uses using this heights and distances. We'll see some example problems. Before going to that, how trigonometrical ratios used in the heights and distance application. Here, observe here. So this is tower. H is height of tower. H is height of tower. Observer observing from this location. Observer means, for example, I am observing from this location. Location A. This bottom of tower is, I can say B. Top of tower C. So that means this is ABC right angled triangle. In right angled triangle, I want to know this distance. I want to know this distance. I want to know if requires this distance also. Of course, I have given here 30 degrees, say theta. In trigonometrical ratios, relation between this height and the distance. So that means if I will take this angle, this is opposite side, this is adjacent side. This is opposite side, this is adjacent side. What is the relation in trigonometry? Tan theta is equal to opposite side by adjacent side. Opposite side by adjacent side. So that means tan theta is equal to h by d. Tan theta is equal to opposite side BC by AB. What is BC here? Tan theta is equal to BC by AB. BC means H. AB means D. Tan theta is equal to H by D. For this connection, tan theta is equal to H by, if such is the condition, particularly this condition, tan theta is equal to H by D. Tan theta is equal to, here I will write H by, if you know any two values, for example, you know distance, you know the angle of elevation, automatically you can find the H. If you know the height of tower, angle of elevation, you can find the distance. Next, same I will write here. This is the clip. This is the angle A, B, C. So this is angle of elevation. This is height of tower. This is the distance from observer to So this is angle theta, or I can say 30 degrees. Very easy, remember that. A person observed a height of the tower with a 30-degree angle from here, and he walked some distance nearer to tower. I can say here, and he observed that from that location. He observed from that location. So that is, I can say, 60 degrees or theta, theta 1, something. Here, there are two distances. From here to here, I can say x. Automatically, this one is, this is overall d. This is x. This is d minus x. You observe particularly in this right angle triangle, there are two right angle triangles. First one is triangle ABC. Second one is triangle DBC. First one is triangle ABC. Second one is here, first triangle ABC. In triangle ABC, tan theta is equal to or tan 30, whatever may be the tan theta is equal to opposite side by adjacent side. Tan theta is equal to opposite side by adjacent side. Particularly triangle ABC, what is the opposite side? BC. What is adjacent side? AB. That is equal to BC means H by AB means D. Tan theta is equal to H by D. Tan theta is equal to H by D. Same this one. Next, you come to some other one. Next, second one. Triangle DBC. In triangle DBC. In triangle DBC, tan theta 1, I can say, because that is a different angle. That is equal to opposite side by adjacent side. What is opposite side here? BC. By what is adjacent side? DB. I will write here. This is number 2. Triangle DBC. Triangle DBC. Tan theta 1 is equal to opposite side by adjacent side. What is opposite side here? BC. By what is adjacent side here? DB. That is, BC means height of the tower, by DB means D minus X. You observe here, particular situation, observed first this top of the tower, first one angle of elevation, then he walked towards the tower, then he observed some other angle of elevation. If such a condition, you can find the, if they may ask, you can find the height or distance from both observer locations or distance from second observer location and height of the tower, whatever they may ask. If such is the condition, this is, I can say, equation number 1. This is, you can say, equation number 2. In the equation number 1 and 2, I think H is common. Directly here, H is common. Here, cross multiply it. H is equal to D tan theta. H is equal to D tan theta. H is equal to D tan theta. I can say this is equation number 1. Instead of this, you can put this. This is equation number 1. Next, from this, H is equal to this D minus X here, it is dividing. You come to this side, multiplying. D minus X into tan theta 1. I can say this is equation number 2. Now, equation number 1 also H is equal to D tan theta. Equation number 2, here H is equal to D minus X tan theta 1. In equation number 1 and 2, H is the same, height is the same. Observer observed from one location that height of the tower with some angle of elevation. Again, he walked towards tower. He observed some angle with the angle of elevation. Same tower. So that means in the both locations, in the both cases, height is the same. In the both cases, height of the tower is the same. So equation number 1, h is equal to d tan theta. Equation number 2, h is equal to d minus x tan theta 1. So you can equate the both. Equation number 1 is equal to equation number 2. Then automatically you may get the d value, x value, if you know the angles. So here also h, here also h. Equation number 1 is equal to equation number 2. Equation number 1 is equal to equation number 2. That is d tan theta is equal to d minus 6 tan theta 1. So this is the final one. Next, third model. Observer seeing this top of the tower with the angle of elevation theta. With the angle of elevation theta. So distance is d, height of tower is h. Then he went to first floor or second floor. Then he has been observed from that location to top of the tower. From that location to top of the tower with the theta 1 angle of elevation. Here also two triangles. First one is, this is one right angle triangle. The second one is, this is other right angle triangle. But here he has been observed from bottom of the floor with the angle of elevation top of the tower. If such is the condition, distance between the observer and bottom of the building and bottom of the tower, distance is same d. Again, he went to the first floor, some height. From there also, he observed the top of the tower. But here also, the distance is same. Here also, distance is same. Here, this is one right angle triangle. This is other right angle triangle. Now, triangle number 1. In triangle ABC, triangle ABC, tan theta is equal to opposite side by adjacent side, that is BC by AB, that is equal to H by D. From here, this is, you observe here, in both the locations, D is common, distance is common. That's why here I will take the D in the common, cross multiply it. D is equal to H by tan theta. This is equation number 1, I can say. Next, in triangle DEC, in triangle DEC, in triangle DAC, here this is x, so that means this is x. From this part, h minus x, this part is x, overall length is height h, so this part is h minus x. Triangle DEC, tan theta 1 is equal to opposite side by adjacent side, that is EC by DE. What is EC? H minus x by DE, D. Now you can cross multiply it, both. D is equal to H minus x by tan theta 1. This is equation number. Equation number 1 is D is equal to H by tan theta. Equation number 2, D is equal to H minus x by tan theta. Both are equated here. Equation number 1 is equal to equation number 2. So that means D is equal to H by tan theta, that is equal to H minus x by tan theta 1. So these are the few examples for angle of elevation. What about the angle of depression? You observe here. Here some bird is flying on top. It has been seen the rat somewhere in the ground with some angle. So in this angle of depression also, you can make it as a right angle. So this is line of sight. This is the angle of depression. Rat is somewhere ground here. So you can draw parallel line to this. You can draw the parallel line to this eyesight. In parallel lines, any transversal line intersecting, the opposite interior angles are equal. The opposite interior angles are equal. Any parallel line, transverse line is intersecting, the alternate interior angles are equal. So this angle is equal to this angle. Bird is here. Now you can write. So this is, I can say height. So this is distance. Now you know very well that A, B, C triangle. This is right angle triangle now. Same formulas. Tan theta is equal to opposite side by adjacent side. Opposite side means tan theta is equal to H by D. So this is one example. Next comes to other example. Next, here one flight. Here flight is flying. This is one end of the river of the bank. This is river. This is one end of the bank. This is other end of the bank. So this flight has been observed the one end of the river of the bank with theta angle. And also he observed the other end of bank with some other angle, theta 1. Same in the same procedure here, in the same parallel lines, opposite interior angles are equal, theta 1. I can say, so width of the river is equal to x, a, b, here c, I can say this is d. Here flight height is same, flight height is same. So this is x, width of the river is equal to x. But here it is, this is overall d, this is d minus x. Now you can take the both the triangles. First triangle number 1 with theta degrees. Next triangle number 2 with theta 1 degrees. In the both cases, h is the same. So you can equate the equation number 1 and 2. So this is second option. Next third option. This flight has been seen the here top of the tower with some angle. That is theta. Here also this is theta. Since both are parallel lines. Again, this is same flight went some distance somewhere here and he has been observed flight. So this is traveled from this distance to this distance. Same flight observed from here to the same top. Same here also the same thing. So this is theta 1. Again this one also theta 1. So this is right angle triangle. This is right angle triangle. This is flight has been observed from one angle to top of the tower, angle of depression. Then it traveled some distance and observed theta 1 degrees angle of depression to the same top of the tower. Now it became two right angles. This is one, this is some other one. But here it is, height is same. Here it is, height is same. Of course, this distance is d. This is traveled distance. From here to here it is x. So this one is d minus x. Now you can easily solve it. Okay friends, these are the few models of heights and distance, that is angle of elevation and angle of depression. In next videos, we are going to solve some problems on angle of elevation and angle of depression. Okay friends, thank you for watching this video. If you are interested, kindly like, subscribe, share our friends group, ask them to subscribe such more practice videos. Thank you very much.